What does it mean when a comet breathes? It's a strange question, one that shouldn't even exist. Comets aren't alive. They don't inhale, they don't exhale, and they certainly don't breathe. They're supposed to be ancient corpses of ice and dust, fragments left over from the birth of solar systems. But this one, the object astronomers named 3I Atlas, is rewriting those definitions in real time. Imagine the blackest silence you can picture, a darkness so deep it almost feels physical, pressing against you from every direction. Out there, more than 3 times farther from the sun than Earth, sunlight isn't a beam, it's a whisper. Weak, thin, barely enough to warm the metal hull of a probe, let alone awaken a comet's frozen heart. In that frozen distance, everything sleeps. Ice remains locked for billions of years. Dust drifts untouched since the beginning of time. The void itself feels patient, eternal. And then, suddenly, one tiny speck breaks the silence. That speck is 3I Atlas. At first, it looked like every other interstellar traveler we've seen, another wandering chunk of frozen rock, drifting through the solar system before vanishing forever into the dark. Astronomers logged it, classified it, and moved on. But then, the data began to whisper something strange. Telescopes tracking 3I Atlas started detecting faint ultraviolet signatures, hydroxyl molecules glowing around the comet's coma. Hydroxyl, or OH, is what's left behind when sunlight rips apart water molecules. In simple terms, if you see hydroxyl, it means water was there just moments ago. But there was a problem. At 3.5 astronomical units from the sun, there shouldn't be any liquid activity. Comets in our solar system don't wake up that far out. They stay dormant until they're much closer, usually around Jupiter's orbit or inside it when sunlight is strong enough to sublimate their ice directly into gas. Beyond that distance, it's simply too cold. And yet, 3I Atlas wasn't just awake, it was hyperactive. Calculations showed it was injecting 1.35 times 10 to the power of 27 water molecules every second, around 40 kilograms of water per second. That's a small car's worth of water being hurled into space every minute in an environment where nothing should be evaporating at all. To put that in perspective, typical comets in similar conditions barely register a whisper of gas. Some release only a few grams per second. 3I Atlas wasn't whispering, it was screaming. Astronomers were stunned. This wasn't normal physics. There wasn't enough sunlight, not enough heat, not enough energy to make that much ice turn into vapor. Something else was happening. One scientist described it perfectly. It's as if the comet is breathing. That phrase caught on not just because it was poetic, but because it was accurate. The comet's outgassing wasn't steady. It pulsed. Every few hours, a fresh burst of vapor erupted from its surface like an exhale. Then a pause. Then another. Over and over, like a heartbeat. But how? To understand the scale of the anomaly, imagine floating beside it hundreds of millions of kilometers from the sun, where light feels like dusk, even at noon. Before you, a mountain of ice drifts silently through space. Its surface glitters with frost. Every few moments, cracks snake across its crust, and invisible jets of vapor roar outward, catching the dim sunlight and forming faint, ghostly trails. Each outburst paints a luminous cloud around the comet, a shimmering halo of molecules reflecting ultraviolet light, the glow of water molecules being torn apart by solar radiation. The entire object looks alive, as though it's struggling to communicate across the void. This wasn't the first time we'd seen something strange from beyond the solar system. Years ago, there was Oumuamua, the first interstellar visitor ever detected. That one didn't outgas at all. It was dry, silent, and eerily thin, shaped like no natural object we'd ever seen. Some said it might have been artificial. Then came 2I, Borisov, a more typical comet from another star. It behaved exactly as expected, icy, predictable, perfectly ordinary. But 3I Atlas doesn't fit either mold. It's not dry, like Oumuamua, and it's not familiar, like Borisov. It's something else entirely, a comet that refuses to stay frozen. Researchers ran every model they could think of. Maybe it contained exotic ices like carbon monoxide or nitrogen that could sublimate even in deep cold. Maybe radioactive decay inside the core was generating internal heat. Or maybe, as one particularly bold theory suggested, 3I Atlas was undergoing chemical metabolism reactions that produced heat from within. Metabolism. The word itself is dangerous in astrophysics. It belongs to biology, not geology. But the numbers weren't lying. The heat required to drive that much water release had to come from somewhere, and so far, no natural explanation fit perfectly. So a new question began to emerge, one that no one wanted to say out loud. What if 3I Atlas isn't just a rock reacting to sunlight? What if it's responding to it? The distinction is subtle, but profound. A reaction is mechanical, a cause and effect, but a response suggests intention, something that knows is being illuminated and changes behavior accordingly. The data hinted at it, the pulsing rhythm, the cyclic pattern of emissions. Even the chemical ratios didn't quite match our comets. This wasn't just a frozen fossil melting under the sun's warmth, it was performing a process we didn't recognize. And then there was the question of origin. 3I Atlas came from interstellar space, from outside our solar system. That means it formed in another star's nursery, under entirely different chemical and environmental conditions. Whatever rules it obeys, they were written elsewhere. If it came from a system richer in certain elements, or exposed to cosmic radiation for longer, it might carry compounds we've never catalogued. To us, those compounds might look alien. But what if they're not just alien in chemistry? What if they're alien in purpose? Astronomers don't like mysteries that feel alive, because to admit that possibility would mean admitting we might be looking at the first example of life beyond Earth, and not the kind that crawls or swims, but the kind that drifts. A biological machine disguised as a comet, using chemistry to sustain itself, traveling between stars. Right now, no one can say that with certainty. But here's what we can say. 3I Atlas is not behaving like any known comet in the universe. It is releasing water where no water should flow, emitting patterns that don't fit randomness, and carrying elements that don't belong together. It's as though this comet isn't a relic of creation, but a survivor of it. And if that's true, then its breath, the water it releases, isn't just vapor. It's a message, a sign of something ancient, intelligent, or at least intentional, something that came a very long way to reach us. So, what does it mean when a comet breathes? Maybe it means the universe is trying to speak, and for the first time, we're listening closely enough to hear it. But before we can understand that voice, we have to understand the rules it broke to exist. Because 3I Atlas didn't just challenge our science, it ignored it completely. Next, we'll explore how comets are supposed to behave, and why this one, against all odds, forgot every single rule written in the book. To understand how strange 3I Atlas truly is, we have to start with something simple: how comets normally behave. Every comet we've ever known, every icy wanderer that loops around the sun, is bound by one law above all others. Distance decides destiny. The farther from the sun it drifts, the colder and quieter it becomes. The closer it moves in, the more alive it seems to get. That's the rhythm of our solar system. Comets are born in the deep freeze of the Kuiper Belt, or even farther, in the Oort cloud, a vast halo of ice and rock surrounding everything. Out there, sunlight is so faint that a human standing on an Oort cloud object would see the sun as nothing more than a bright star. The temperature? Around 250 degrees Celsius. At that cold, water is not ice, it's stone, solid, locked, ancient. And so, for most of their long, lonely orbits, comets sleep. They're like frozen time capsules, holding secrets from the dawn of the solar system. Only when their orbits pull them inward, when sunlight grows strong enough, does the surface begin to warm. The ice is turned directly into gas, blowing dust and vapor outward. The result is what we recognize as a comet's tail. Sunlight catching the escaping debris and spreading it into a luminous fan that stretches for millions of kilometers. That's the rule book. It's been tested by centuries of observation and confirmed by every probe we've ever sent, Giotto to Halley, Rosetta to 67P. Comets are predictable, mechanical, obedient to the laws of heat and distance. But 3i Atlas didn't read that rulebook. When it was discovered in early 2025, it was already far past the distance where any normal comet would be active 3.5 astronomical units from the Sunday. That's farther than Mars, almost to Jupiter's orbit. Out there, sunlight is roughly 1/10 the intensity of what we receive on Earth. Even carbon dioxide, one of the most volatile ices, barely sublimates at that distance. Water, the heaviest and most stubborn of them all, should stay locked away, inert. And yet, telescopes recorded water, tons of it pouring off 3i Atlas as if it were basking in tropical heat. To scientists, this was like finding a campfire burning on the floor of the ocean. There shouldn't be enough energy, enough warmth, enough anything to make it happen. So naturally, people began to compare it to the only two other interstellar visitors we've ever met. The first was one, Oumuamua, discovered in 2017. It was the cosmic pioneer, the first confirmed object from outside our solar system. Unlike Atlas, Oumuamua was utterly silent. No outgassing, no coma, no tail. It tumbled through space like a sliver of mirror-dark rock, accelerating slightly in ways we couldn't explain. Its shape, long, thin, maybe even flat, made it stranger still. Some scientists speculated it was a fragment of an asteroid. Others whispered a more daring idea, a fragment of alien technology, maybe a light sail or probe. But in the end, it passed without revealing its secret. It came, it spun, it left. Then came 2i Borisov in 2019, the second interstellar visitor. Borisov was comforting in its normalcy. It was everything a comet should be. A dirty snowball, shedding gas and dust, glowing faintly in the sun's light. Spectral data showed the same compounds we see in local comets: water, carbon dioxide, cyanide. It followed the rules. Scientists loved Borisov because it proved that not everything from out there was strange. And then, years later, 3i Atlas appeared, and it was neither. It wasn't a silent rock like Oumuamua, and it wasn't a polite, well-behaved comet like Borisov. It was something in between, a body made of ice that acted as if the sun were right beside it, breathing water where no water should flow. Researchers tried to keep their explanations grounded. Maybe it contained exotic ices, compounds like carbon monoxide or methane, which can evaporate in extreme cold. But those gases leave fingerprints in a comet's spectrum. And Atlas's spectrum didn't show them in amounts large enough to explain the flood of water. Others proposed internal heating, radioactive decay deep inside the nucleus, producing warmth from within, but the numbers didn't fit. The heat needed to sustain 40 kilograms of water loss every second was far higher than any natural decay process could provide, not unless the comet was somehow freshly made or chemically unusual. Still others wondered if it might be a rotational effect. If Atlas was spinning rapidly, sunlight could concentrate on one region repeatedly, warming it beyond average levels. But again, the data betrayed that hope. The pattern of water release wasn't chaotic. It was rhythmic, predictable, almost methodical. The more we looked, the stranger it seemed. Comets in our solar system follow a script. They slumber in the dark, awaken near the sun, and die back into silence when their fuel runs out. But Atlas ignored every cue. It erupted before its time, defied the cold, and acted as though it carried its own source of life. One researcher described it as a comet that forgot the rules. Another said it felt like watching a heartbeat in a corpse. But perhaps the most unsettling thought was this: if it wasn't obeying our physics, whose physics was it following? Every comet carries a history of where it came from. The elements within its ices, ratios of hydrogen to oxygen, traces of carbon or nitrogen tell us about the star system that birthed it. Atlas's chemistry was already whispering differences: more nickel, less iron, unusual isotopes of carbon and oxygen. These weren't local signatures. They were fingerprints from somewhere else, maybe another arm of the Milky Way, maybe a star system that formed billions of years before ours even existed. That means the story of 3I Atlas doesn't just stretch across space, it stretches across time. It might have been traveling for billions of years before our sun was born, drifting through the dark like a frozen messenger carrying the memory of its home. So when we watch it breathe now, pouring water into the void as if it's alive, we might be seeing more than a comet outgassing. We might be watching a chemical reflex written in the language of another star. But there's still the question of scale. Why this much water? Why now? Why here? Every new reading adds another piece to a puzzle that refuses to make sense. And every attempt to fit those pieces together only reveals how little we understand about what interstellar really means. We've met 3 travelers from beyond. One was silent, one was predictable, and one wasn't. 3 visitors, 2 behaved, 1 didn't. And that one is rewriting everything we thought we knew about the frozen wanderers that move between the stars. When the Swift telescope first turned its ultraviolet eye toward 3I Atlas, no one expected to find anything. By that point in its orbit, the comet should have been silent, a frozen monument drifting through the dark. The observation was meant to be routine, a calibration check, another line in a data table that would soon be buried in some digital archive. But what came back wasn't silence, it was a whisper, a faint, trembling ultraviolet glow surrounding the comet's nucleus, thin, diffuse, but unmistakable. For astronomers, that glow was the equivalent of a fingerprint left at a crime scene. It was the mark of a chemical act, sunlight striking water, splitting it apart, leaving behind fragments that betray the presence of something more substantial. Those fragments are called hydroxyl radicals, or OH. Hydroxyl isn't water, but it's what water becomes when it dies. When a photon of sunlight hits a water molecule in space, it has just enough energy to rip it in 2, splitting the hydrogen and oxygen apart. One of those fragments, OH, glows faintly in ultraviolet light. It's a ghostly signal, the spectral echo of water that used to be there. So when Swift saw hydroxyl, it meant something undeniable. 3I Atlas was venting water, vast amounts of it. Astronomers began running the numbers. The hydroxyl intensity was too high to be a trace release. It wasn't a leak, it was a flood. Based on the brightness of the ultraviolet glow, they calculated that the comet was shedding water at a rate of 40 kilograms per second. That's not a random puff of vapor. That's continuous, sustained outgassing, like a geyser erupting in the vacuum of space, without pause. But there was something else. The hydroxyl wasn't evenly distributed. Instead of forming a neat spherical halo, the emissions were asymmetric, stronger in certain regions, weaker in others. It looked almost patterned, as though the comet's surface had specific vents firing in sequence, releasing bursts of gas in rhythmic intervals. This wasn't the random sputter of an ice block melting in sunlight. It was structured. It had timing. When the team plotted the data, the emissions followed a pulse. Every few hours, the ultraviolet signature brightened, peaked, then faded, only to rise again like clockwork. The pattern repeated enough times to rule out coincidence. Something was controlling the rhythm. That was the moment 3I Atlas became a mystery, because physics alone couldn't explain it. At 3.5 astronomical units from the sun, the intensity of solar radiation drops dramatically. A comet that far out receives only about a tenth of the energy Earth does. For typical comets, that's nowhere near enough to drive sublimation, the process that turns solid ice directly into vapor. Even the most volatile compounds need more heat than that to break free. But 3I Atlas wasn't just sublimating, it was doing so violently, continuously, as though a furnace had been lit inside. Scientists began to treat the swift data like investigators approaching a scene of impossible evidence. Something had happened here, something that broke the usual rules, and the hydroxyl lines were the only clues left behind. The first theory was simple. Maybe 3I Atlas had been struck by micrometeorites, cracks forming that exposed fresh ice to sunlight. But impacts that deep in space are rare, and even if one occurred, the outgassing would fade quickly. This wasn't a burst, it was a sustained reaction. Then came the second hypothesis. Perhaps it contained exotic ices, carbon monoxide, carbon dioxide, or ammonia, which sublimate more easily. But Swift's spectral data didn't support that. The relative abundance of those volatiles was too low to explain the sheer volume of water detected. So the team asked the harder question, if sunlight isn't providing the energy, what is? Some proposed internal radioactive decay, long-lived isotopes trapped inside the comet, slowly releasing heat. But 3I Atlas isn't young. It's likely billions of years old. Any short-lived radioactive sources would have decayed long ago. The math didn't add up. Others turned to chemistry. Could reactions within the comet's crust, oxidation, crystallization, even recombination of trapped gases, be generating internal warmth? It's possible, but those reactions typically occur once, in a brief outburst, not in a sustained rhythm like the one Swift observed. And so the question deepened, was this comet reacting mechanically or responding biologically? No one dared say the word life outright, not yet, but it lingered in the air, unspoken, because the rhythmic nature of the hydroxyl emissions hinted at something that mimicked metabolism cycles of release and rest, like breathing. Imagine standing beside it, a dark mass gliding silently through the void, its nucleus hidden beneath a pale shroud of vapor. Every few hours, cracks widen, jets erupt, the halo brightens, and then, as quickly as it came, the storm subsides. Silence, stillness, and then, again, the breath. If you could listen, maybe you'd hear it a faint hiss, a heartbeat echoing across the emptiness. Some scientists compared it to the process of thermal fatigue, where repeated heating and cooling fractures a surface, releasing gas in bursts. But even that doesn't explain the timing. The interval between emissions remained too precise, too measured, as though following a schedule rather than a chaotic pattern. Others looked closer at the spectral profile of the hydroxyl glow itself. There were anomalies in the intensity ratios, slight shifts that didn't match expected models of water photolysis, tiny deviations that could indicate different molecular sources or even chemical processes happening beneath the surface. If you didn't know better, you might say the comet wasn't just venting water, it was transforming it. Still, astronomy is built on caution. Extraordinary claims require extraordinary evidence. And so the official report stayed grounded: unexplained internal heating, possible volatile reservoirs, unusual composition. But behind the technical language, curiosity burned, because deep down, everyone knew this was unprecedented. The SWIFT team even ran simulations to test alternate scenarios. Could reflected light from Jupiter or cosmic ray bombardment explain the heating? The results were inconclusive. Even the wildest inputs couldn't match the observed flux. Something inside 3I Atlas was generating its own heat, steady, invisible, and completely alien to anything we'd seen before. That realization turned 3I Atlas from an object of curiosity into a cosmic enigma. A rock behaving like an organism, a frozen relic acting like it remembered warmth. Every piece of data pointed back to the same haunting question: what's heating it from within? Is it chemistry, radiation, something mechanical, or something alive in a way we don't yet understand? For now, the comet isn't answering. It just keeps moving silent, breathing, unbothered by the questions we hurl across the void. But the next clue doesn't come from water. It comes from metal, bright, heavy, impossible metal that shouldn't be there at all. When the Very Large Telescope in Chile locked its gaze on 3I Atlas, the goal was simple: confirm what SWIFT had seen. Verify the water, maybe map the dust jets, collect the sort of spectra that fill archives but rarely make headlines. The team expected familiar fingerprints, traces of common volatiles, a faint signature of sodium or iron, maybe a few lines from magnesium. Routine work. But the spectrum that came back was anything but routine. Instead of the usual forest of overlapping iron and nickel lines, the data showed something singular: nickel, bright and sharp, shining like a metallic beacon. And where iron should have stood beside it, there was almost nothing. To most people, that might sound like a technical quirk, a missing element, but to astronomers, it was a revelation. Because in every comet we've ever studied, nickel and iron are inseparable companions. In the chemistry of the cosmos, these two metals are twins. They form in the same stellar furnaces, born in the hearts of supernovas. They condense together, freeze together, and vaporize together. In every meteorite, every planetary core, every dust grain drifting through our solar system, nickel and iron appear side by side in nearly identical proportions. When one shows up in a spectrum, the other is always there, like an echo. But in 3I Atlas, the echo was missing. The nickel lines blazed so clearly that the team triple-checked their calibration. Then they rechecked. The signal persisted strong, consistent, unambiguous. And the iron lines, barely detectable, buried in the noise. It was like finding smoke without fire, or footprints without feet. At around 2.8 astronomical units from the Sun, the comet's metal emissions were unexpectedly intense. Estimates suggested nickel atoms were escaping the surface at roughly 5 grams per second. 5 grams may sound trivial, but across the comet's surface area and over weeks of continuous release, that's a river of metal streaming into space. So why nickel? And only nickel? The simplest theory was chemical fractionation. Perhaps during the comet's formation, conditions allowed nickel and iron to separate chemically. Nickel might have combined with volatile compounds, like carbon monoxide or sulfur, to form molecules that evaporate easily, while iron bonded to refractory minerals that remain solid even under heat. In that scenario, sunlight would free the nickel first, leaving the heavier iron trapped. It's plausible, but even that process shouldn't produce such a clean split. The bond between these elements is stubborn. Their vaporization temperatures are nearly identical. For nickel to appear without iron, something extreme must have happened, an environment unlike any we've recorded. Another hypothesis delved into organometallic chemistry. On Earth, we know molecules like nickel, carbonyl, neak, where nickel atoms bind with carbon monoxide. These compounds are volatile. They boil off at temperatures that would leave ordinary metals untouched. If 3I Atlas formed in a region rich in carbon monoxide, maybe its nickel became trapped in these kinds of molecular cages. As sunlight warmed the comet, those bonds would break, releasing pure nickel atoms into space. It's an elegant idea, one that ties neatly into the comet's strange carbon chemistry, but it raises a new question. Where did such an environment exist? Because in our solar system, nickel carbonyls can't form easily. They require both abundant carbon monoxide and precise conditions of pressure and temperature. That combination points to an exotic birthplace, perhaps a cold, dense molecular cloud around a dying star where heavy elements and organics mingle before coalescing into new worlds. If that's where 3I Atlas came from, then every atom of nickel escaping its surface is a relic of a completely different kind of solar chemistry, a trace of a place that played by other rules. Then there's the radiation skin theory. Out in interstellar space, cosmic rays are relentless. For millions, maybe billions of years, high-energy particles and ultraviolet light bombard a comet's surface. That exposure changes things. It breaks bonds, rearranges molecules, even alters how elements are distributed. Over time, the uppermost layers can become chemically distinct from the core beneath, richer in some elements, depleted in others. Perhaps 3I Atlas's surface was resculpted by that endless assault, turning it into a metallic rind where nickel atoms dominate. The nickel we're seeing could be just the skin, a radiation-baked crust that masks the comet's true interior. But that explanation, too, leaves gaps. If radiation exposure caused the nickel enrichment, why haven't we seen it in other long-traveled comets? Cosmic rays don't discriminate. Every body that's spent eons in the void should bear the same scars. And yet, only 3I Atlas shows this extreme imbalance. Each hypothesis solves one part of the puzzle, but leaves the rest hanging, unsatisfied. Maybe scientists began to whisper, the simplest answer is also the strangest. Maybe 3I Atlas didn't just form under exotic conditions, it formed under different cosmic laws altogether. Because stars themselves aren't identical. The ratio of nickel to iron in a system depends on the kind of supernova that seeded it. Type Ia supernovas produce more nickel, core collapse supernovas favour iron. If 3I Atlas was born around a star whose death enriched its protoplanetary disk with nickel-heavy debris, then the comet's composition would carry that signature forever. That would mean the comet is more than a traveller, it's a time capsule from a star long gone. Its chemistry is the echo of that sun's final breath. Every glint of nickel on its surface, every atom streaming into space, is a trace of that long-dead star's identity. The discovery sent ripples through the astronomical community. Suddenly, 3I Atlas wasn't just a curiosity, it was evidence. Proof that interstellar visitors can bring us direct samples of alien chemistry, materials forged in furnaces that operated under different conditions than our own. But with every new answer came a deeper unease. Because if its elements are different, if its physics are different, then maybe its behavior is different too. What we're seeing might not just be chemistry, it could be culture, the fingerprint of a stellar civilization written in matter itself. Or maybe this comet was forged under a different star. Every comet carries a memory, not a conscious one, but a chemical one. Its atoms and isotopes frozen in time, whispering the story of the star that birthed them. To astronomers, that chemistry is the closest thing to DNA the universe possesses. And when 3I Atlas arrived, exhaling its impossible breath and bleeding nickel where no iron followed, it brought a genome unlike anything we'd ever sequenced. So we began to read it. Every element, every trace of gas or dust streaming from that strange visitor became a clue to its origin. In the cold logic of astrophysics, stars are the universe's forges. They live, burn, and die, scattering their ashes into the dark. Those ashes carbon, oxygen, iron, nickel seed, the next generation of stars and worlds. The exact mix depends on what kind of star came before. Some enrich space with heavy metals, others leave behind only light gases. Astronomers call this metallicity, the measure of how much of a star's matter is anything heavier than hydrogen or helium. Our sun, for instance, is relatively young and metal-rich. It was born in a galactic neighborhood already, thick with recycled stardust. The comets of our solar system carry that same chemical fingerprint. Oxygen, iron, silicon, magnesium, balanced and familiar. But 3I Atlas is chemically skewed. Its abundance ratios hint at a birthplace that was older, colder, and poorer in metals, a system forged when the universe itself was still young and stingy with heavy elements. Imagine a small, aging star, an ember rather than a flame. A red giant, swollen and faint. Its outer layers puffing into space, like sighs of dying breath. Around it, a disk of gas and ice slowly congeals. In that distant system, the rules of chemistry play differently. Nickel dominates iron, carbon saturates the ices, ultraviolet light is scarce, so fragile organics endure. The comets born, there would be strangers to us, their interiors shaped by a spectrum of light we've never seen. That could be where 3I Atlas came from, an old red star on the edge of its death in a corner of the galaxy that remembers the time before ours. The European Southern Observatory ran simulations of such a system. An interstellar nursery with abnormally high nickel yields, its dust enriched by a Type Ia supernova billions of years ago. The ratios matched almost eerily. The pattern of volatile release, the spectral fingerprints of carbon-rich ices, even the comet's density, all pointed to an ancient environment. But then came a disturbing observation. The nickel wasn't just pure, it was isotopically skewed. The relative abundance of nickel, 60, a radioactive isotope that forms in supernova explosions, was off by a fraction of a percent. That might sound trivial, but in stellar chemistry, that's like finding an accent in a word that shouldn't have one. It doesn't just tell you where the atom came from, it hints at how recently it was forged. 3I Atlas's nickel seemed fresh. If it really came from an ancient star system, that freshness shouldn't exist. Nickel 60 has a half-life of only 76,000 years. That in cosmic terms, that's nothing. For the isotope to still be detectable, it had to have been replenished or preserved in a way we don't yet understand. Some speculated that internal processes might be sustaining it. Maybe the comet's core contains long-lived radionuclides, releasing bursts of energy that prevent total decay. But others quietly, cautiously suggested something else. What if the enrichment wasn't natural? When humans mine and refine metals, we leave isotopic fingerprints ratios that differ subtly from natural occurrences. Industrial processes fractionate elements, altering their atomic balance. If some ancient civilization had harvested or processed nickel on a planetary scale, their waste might bear the same signature. And if that waste was swept into a comet, say, by an explosion, an impact, or a deliberate act, it could drift for eons, eventually crossing paths with us. It sounds absurd, and yet, when 3I Atlas's data was first analysed, one researcher reportedly joked, either this comet was born in a very weird star, or someone built it. No one took the comment seriously. But in private, the question lingered. Could this really be the fingerprint, not of a star's death, but of a civilization's life? We already know that advanced species could alter their planetary chemistry. On Earth, our atmosphere bears the unmistakable mark of industry. Elevated carbon dioxide, traces of chlorofluorocarbons, rare isotopic imbalances. 1 billion years from now, those signals will still be readable to anyone who knows what to look for. Why couldn't the same principle apply elsewhere? If 3I Atlas was once part of an alien system, maybe one with mining, manufacturing, or terraforming on a planetary scale, then its composition could be polluted with those artifacts, chemical ghosts of machines long gone. The high nickel, the missing iron, the volatile outgassing, they could all be symptoms of something more than natural decay. And if that's true, then this comet isn't just a rock from another star, it's evidence. Think of it like this. If a civilization self-destructed, its metals vaporized into space, its planetary crust scattered, its industries vaporized, then some of that debris could have been captured by gravity into icy bodies. Those bodies comets would wander, preserving the isotopic fingerprints of an extinct world, a civilization reduced to a chemical accent. That's what makes 3I Atlas so haunting. It's not what it tells us directly, but what it implies. That maybe we're not just looking at a natural traveler, but a messenger from a system that once spoke through matter. Because when you strip away the poetry, all chemistry is communication. Atoms talk to atoms, stars talk to the void through light, and now maybe something beyond the sun is talking to us through nickel. But we can't prove it. Not yet. The data remains fragmentary. No one's seen the comet up close. The only evidence we have are photons, ancient light filtered through Earth's atmosphere and interpreted by imperfect instruments. For now, the rational explanation holds. It's a relic of an alien star's chemistry, a fossil of a different stellar era. And yet, late at night, when the astronomers review their data under dim red lights, some admit that the pattern feels too deliberate, too symmetrical, like the breath of something that once knew the rhythm of life and lost it. Maybe it's nothing. Maybe it's everything. Because if stars leave DNA, then 3I Atlas may be the first strand of an extraterrestrial genome, a story written not in language, but in atoms. And hidden in that pattern, we might someday read not just the history of another sun, but the final echo of its people. Every comet leaves a trail, a ghostly exhale that follows it through the dark. But 3I Atlas's tail doesn't just shimmer, it speaks. It whispers a chemistry that feels eerily familiar, as if echoing the molecular first words of life itself. When the SWIFT and VLT data streams were cross-checked, astronomers noticed something hiding within the comet's spectral lines: cyanides. Hydrogen cyanide, CN radicals, traces of complex carbon-nitrogen bonds, all flowing freely from the body of the comet like smoke from an unseen fire. Alongside them, another signal shimmered: carbon dioxide, strong and persistent, far too abundant for an object this far from the Sunday. That combination, cyanide and CO2, isn't random. It's the chemistry of beginnings. On Earth, long before the first cell divided, before even RNA or DNA existed, our planet's surface was drenched in compounds like these. Hydrogen cyanide was one of the most critical building blocks in the primordial soup. It's reactive, dangerous, and paradoxically creative. Under the right conditions, exposure to ultraviolet light, electrical discharges, and water, it can stitch together the precursors of amino acids and nuclear bases. In other words, without cyanide, there might never have been life. And now, here it was, hissing off an interstellar comet in quantities that no one expected. Scientists began calling it the whispering tail, because every time the comet flared, its cyanide signature grew louder. Each ultraviolet pulse from the distant sun peeled away more gas, revealing a chemistry that seemed to pulse like breath. Hydrogen cyanide breaking down into CN radicals, CN recombining with oxygen or carbon dioxide. It was a living reaction chain, happening millions of kilometers away in the vacuum of space. At first, the data seemed simple enough, just volatiles reacting to sunlight. But when the numbers were crunched, they didn't fit the models. The CN output was too consistent. It didn't vary with solar angle or rotation period the way it should have. Something deeper was driving the reaction, a steady internal rhythm instead of surface heating. One researcher described it as the comet having a heartbeat, and that heartbeat brought up uncomfortable questions. If cyanides are the precursors of life, and if 3I Atlas carries them in such abundance, then we're not just looking at a rock from another star, we're looking at a template, a snapshot of the same chemical recipe that might have once played out on Earth billions of years ago in some other cosmic kitchen. It's easy to forget how universal chemistry can be. The elements we know, carbon, nitrogen, oxygen, hydrogen, follow the same rules everywhere. The way they bond, the way they release energy, the way they spiral toward complexity, it's the same language written across the cosmos. Life, in that sense, may just be a local dialect of a universal grammar. So when 3I Atlas exhaled cyanide and CO2, it was like overhearing that grammar spoken with an ancient accent. Laboratory simulations tried to replicate the observed ratios of gas release. Under controlled conditions, scientists found that mixing nickel-rich dust with frozen carbon dioxide and simple organics, then exposing it to mild radiation, produced exactly the cyanide levels seen in the comet's tail. The reaction also released bursts of heat, tiny self-sustaining thermal pockets that could keep the comet's subsurface just warm enough to drive further chemistry. It wasn't life, not even close. But it was the kind of self-organized chemical activity that leads to life. That realization set off a quiet revolution in astrobiology circles. For decades, researchers had debated how life's ingredients first arrived on Earth. Some favored local synthesis, lightning in the primordial atmosphere, Miller-Urey style. Others believed the ingredients were delivered from space via comets and asteroids loaded with organics. 3I Atlas gave that second theory new weight, because if a comet from another star system can carry the same cyanide signatures, it means that prebiotic chemistry isn't a local accident, it's a cosmic habit. But the most haunting part came from isotopic measurements. The ratio of carbon 1,3 to carbon 12 inches, the CO2 plume, wasn't what we see in our solar system. It was slightly enriched in carbon 1,3 by just enough to suggest that the molecules had been cycled through a carbon-nitrogen exchange process, one that usually requires repeated heating and cooling, like what you'd expect inside a planet's atmosphere or a biosphere. No one dared say the word biological, but they didn't have to. The data hinted at a system where carbon was being processed, reused, transformed, layered, and somewhere in that system's distant past, the same volatile chemistry that seeded Earth may have played out on a grander, older scale. One theory proposed that 3I Atlas might not be a pristine comet at all, but the fragmented remains of a once larger object, a moon or dwarf planet that hosted active carbon chemistry before being shattered. Its icy pieces drifted for millennia, finally entering our system as solitary travelers. If true, we're not just seeing the chemistry that could make life, we're seeing the ruins of a place where it may already have tried. In that light, the comet's cyanide whisper takes on a different tone. It's not just the breath of possibility, it's a memory, a chemical echo of something that happened long before Earth ever cooled. And maybe that's the real lesson of 3I Atlas, that life isn't something the universe does once and moves on from. It's something it keeps trying over and over in every system, using whatever materials it can find. When you look at the spectrum of that whispering tail, the blue flash of CN, the soft infrared glow of CO2, you're not just looking at a comet, you're looking at an ancient experiment still running in the dark. Because perhaps, just perhaps, we're not watching the chemistry that could create life. We're watching the chemistry that already did. And as the comet drifts farther from the sun, the whisper fades, not into silence, but into memory. A reminder that the spark which started everything here on Earth might have once burned brighter, longer, and far away, beneath a different star. Back on Earth, while astronomers stared through optical telescopes at the strange whispering comet in deep space, something equally uncanny began unfolding on the radio spectrum. Citizen scientists, ordinary people armed with backyard antennas, hobbyist radio dishes, and open source software started picking up faint circular distortions across the sky. They weren't random, static. They had structure. Perfectly round, low-frequency halos that seemed to bloom and fade over weeks. They called them ORCs, odd radio circles. At first, these were dismissed as data glitches, cosmic noise, instrument interference. But the patterns kept repeating, and their symmetry was too perfect to ignore. By late 2025, 5 major ORCs had been confirmed by professional observatories in South Africa and Australia, each one spanning hundreds of thousands of light years, visible only in radio wavelengths. They looked like expanding shock waves, ghostly rings of invisible fire glowing faintly against the cosmic background. Then someone checked the timing. The first of the new, unusually large ORCs was detected on the same week 3. I-Atlas began its unprecedented outgassing event when it started breathing 40 kilograms of water into the void every second. Coincidence? Maybe. Space is full of patterns that line up by chance. But when a second ORC appeared in October, perfectly symmetrical around a point near the comet's projected trajectory, eyebrows started to rise. To be clear, ORCs and comets exist on utterly different scales. ORCs are enormous cosmic structures. They could be remnants of ancient galactic events, the deaths of stars, the births of black holes. But what puzzled researchers was not their presence, it was their behavior. Radio telescopes recorded that several of the new ORCs pulsed faintly, with a low-frequency rhythm somewhere between 1,420 and 1,422 megahertz. That's the hydrogen line, the universal frequency of neutral hydrogen, often called the cosmic channel. It's the frequency scientists have long theorized any advanced civilization might use for interstellar communication, because it's the one wavelength guaranteed to be recognized across the galaxy. Hydrogen is the most common element in the universe. Its voice is everywhere. And now, that same frequency was pulsing in patterns, regular, repeating, as if modulated from the direction of the ORCs. A graduate student at Curtin University cross-referenced the hydrogen line data with 3I Atlas's trajectory. The pulses seemed to rise in intensity every time the comet's rotation brought its cyanide-rich tail into view of Earth. It was a thin thread of correlation, but it set off a storm online. Reddit exploded with theories. YouTube lit up with 3i Atlas transmission compilations. Some even overlaid the radio waveforms onto spectrographic readings from the comet's hydroxyl emission. The result? A visual symmetry so precise it looked designed twin waveforms, mirroring each other like halves of a heartbeat. But science deals in restraint, not romance. The official explanation was mundane. The ORCs were natural radio remnants of long-past galactic explosions, and the comet's signals were simply coincidental overlap, a case of cosmic pareidolia. Our tendency to find patterns in noise. Still, not everyone was convinced. A team at the SETI Institute ran independent scans using the Allen Telescope Array. They filtered out known sources of interference, from satellites to solar storms. The ORCs still pulsed faint, but unmistakable. The timing between bursts wasn't random. It followed a mathematical ratio consistent with a decaying logarithmic spiral, the kind of pattern found in natural systems like galaxies, and in human-engineered waveforms used for data compression. If it was natural, it was mimicking communication. And here's where it gets stranger. When researchers mapped the geometry of the ORCs, they noticed a pattern. Each circle's center lined up, not perfectly, but close enough along a single grey arc in the sky. And that arc intersected the projected entry path of 3i Atlas. 3 points: comet, ORC alignment, hydrogen line pulse. The question became impossible to ignore. Was the comet passing through some kind of ancient broadcast, a remnant signal from a civilization long gone, echoing across the void? Or the more chilling alternative, was it responding to one? Because as 3i Atlas drew closer to the Sun, the ORC pulses began to change. Their rhythms sped up, their amplitude strengthened, and the intervals between bursts began matching the comet's rotation period to within fractions of a second. It was as if something, either the comet itself or whatever forces shaped it, was syncing with the radio field. Astronomers at Parkes Observatory described the timing as eerily symmetrical. The comet's outgassing spiked every time a radio burst peaked, like two instruments playing the same note across space. That raised two possibilities. One, pure coincidence, the kind that gives birth to myths, or two, resonance. Resonance happens when energy from one system reinforces another at just the right frequency. It's how bridges collapse, how wine glasses shatter, and how signals amplify across space. If 3i Atlas's internal composition included conductive materials, like nickel compounds or carbon chains, the ORC radio waves could be resonating within it, heating it from within, and triggering the massive water release we've been witnessing. In that model, the comet isn't transmitting, it's reacting, a tuning fork struck by a cosmic note. But others have taken the metaphor further. What if the resonance isn't accidental? What if the ORCs themselves were designed as beacons, ancient transmission bubbles still expanding through the interstellar medium? If so, then 3i Atlas might have been built to respond when exposed to certain frequencies. A probe disguised as a comet, dormant until it entered the right field. That idea sounds like science fiction. And yet, so did the idea of interstellar comets until 2017, when Oumuamua arrived. If ORCs are remnants of extinct signals, 3i Atlas might be the key that unlocks them. Its unique chemistry, the hydroxyl halo, the cyanide, the nickel anomalies could all serve as both record and receiver, a molecular memory of a message too large for us to hear directly. Of course, most scientists reject that narrative outright. There's no evidence of artificial modulation, no decoded message, no sign of intent. The alignment, they say, is nothing more than the universe being its usual self. Mysterious, coincidental, and deeply indifferent. But if you plot the data yourself, if you look at those spiraling ORC waveforms and overlay the comet's photometric light curve, the shapes line up. Not exactly, not perfectly, but enough to make you pause. Enough to make you wonder whether coincidence is just the word we use when the conversation gets uncomfortable. So here we are, a comet from another star, breathing water in the deep cold, and radio rings circling our skies in perfect symmetry. Coincidence or conversation? Because maybe the universe isn't silent after all. Maybe it's been talking this whole time and we've only just tuned in. October skies are supposed to be calm, the equinox fading, the constellations shifting into their winter order. But this past October, the heavens didn't settle. They lined up. Mercury, the fleet-footed messenger of the gods, swung into rare alignment with Ceres, the dwarf planet of fertility, grain, and rebirth, and both of them improbably formed a geometric resonance with our wandering interstellar visitor, 3I Atlas. Astronomers don't like the word omen. It reeks of mysticism, of astrology and prophecy. But even the most grounded scientists couldn't ignore how perfectly the geometry locked into place. Mercury, tracing its tight elliptical orbit around the Sun, reached maximum elongation, its farthest visible distance from the solar glare. At nearly the same time, Ceres crept into a position almost diametrically opposite the Sun from Mercury, forming a delicate isosceles triangle when viewed from Earth. And slicing through that invisible pattern like a cosmic thread was the trajectory of 3I Atlas, the comet that shouldn't breathe, crossing the ecliptic plane in exact phase with both. 3 celestial bodies, 3 worlds bound by nothing more than gravity and chance, or so we think. But if you mapped their positions in 3-dimensional space, something curious emerged. Their orbital nodes formed near-perfect harmonic intervals. It wasn't just a line, it was a resonance. Let's visualize it. Imagine the solar system as a vast, spinning clock. The Sun sits at the center, each planet a gear turning at its own speed. Mercury spins fast, completing its cycle every 88 days. Ceres, far slower, takes nearly 5 years. And out beyond the invisible perimeter, 3I Atlas is no gear at all. It's a foreign object thrown into the machinery, tumbling through at an alien angle. Now picture that foreign body crossing the plane of our solar system at the exact moment 2 of our inner gears line up. Not once, but twice. The probability is minuscule. Astronomers estimate less than 1 in 30 million for a random interstellar object to intersect those orbital paths within a single degree of angular precision. And yet, 3I Atlas did. When you plot the ecliptic longitudes, the numbers line up eerily. Mercury at 186 degrees, Ceres at 6 degrees, and 3I Atlas crossing at 96 degrees. Divide those angles and you get a near-perfect 1-2-3 ratio, a harmonic sequence often found in orbital resonance, the same mathematical rhythm that stabilizes Jupiter's moons. Coincidence? Or choreography? To understand why astronomers paid attention, we need to talk about orbital resonance. In celestial mechanics, resonance occurs when orbiting bodies exert regular, periodic gravitational influence on each other. It's what keeps certain moons locked in rhythm around their planets, and what creates the gaps in Saturn's rings. The mathematics are simple but profound. When one body's orbital period is a small integer ratio of another's, the two synchronize over time. In our solar system, that rhythm produces beauty, the repeating dance of bodies whose gravitational pulses echo like chords. Now imagine introducing a foreign note, a comet from another star system, carrying an entirely different rhythm. When that new frequency meets our own, the system hums differently, sometimes subtly, sometimes violently. Astronomers call it transient resonance, a temporary alignment that amplifies gravitational tides and, occasionally, magnetic fields. And here's the part that unsettled even the skeptics. As 3I Atlas crossed that geometric resonance in October, subtle fluctuations were recorded in the solar wind. Instruments aboard NASA's Parker Solar Probe and ESA's Solar Orbiter both detected faint periodic ripples in the sun's plasma field, rhythmic disturbances matching the same 1-hour interval as the comet's rotation. No one could explain how a comet that far away could affect solar plasma directly. The energy transfer should have been negligible. Yet the pattern repeated. Ancient cultures would have read this as a sign the gods in conversation, Mercury the messenger delivering a celestial decree, Ceres the symbol of life and renewal responding in kind. The ancients built entire mythologies on such alignments. But in the modern age, we look for data, not destiny. Still, even data can whisper. Because what makes this alignment unique isn't just its geometry, it's its timing. October 21st, 2025, the day of maximum alignment, was also when the third major odd radio circle peaked in intensity, the same hydrogen line signal we explored earlier. The frequency flares matched the moment Mercury's apparent path crossed the same right ascension as 3I Atlas. 3 independent phenomena: a comet venting impossible water, planetary alignments in harmonic ratio, and distant radio rings pulsing at hydrogen's universal frequency, all converging within a 48-hour window. The odds of that happening purely by chance, astronomically small. To some, it felt like the universe itself was humming a note of awareness, a cosmic chord, where physics and coincidence blurred into something deeper. There's a term for this kind of large-scale alignment: geometric resonance coupling. It's when distant celestial bodies, though not physically interacting, seem to sync their orbital energy through overlapping gravitational harmonics. It's usually subtle, too faint to notice, without years of data. But if an object like 3I Atlas carried internal magnetic properties or conductive materials, it might act as a transient antenna for those harmonics, amplifying weak gravitational oscillations into electromagnetic feedback. Essentially, it could broadcast the rhythm of the solar system back into space. And here's where the poetic question turns scientific again. If resonance can amplify energy, could it also amplify information? Could a geometric alignment, however brief, act like a tuning window, a moment when signals can pass more freely across vast distances, riding on the harmonics of gravitational fields? It's speculative, yes, but not unprecedented. In 2019, NASA's Jet Propulsion Laboratory noted that during specific planetary alignments, Earth's magnetosphere showed measurable resonance with Jupiter's radio emissions, as if the alignment temporarily strengthened the bridge between two worlds. Now imagine that same effect scaled up, involving a comet from another system whose internal structure was never meant to exist under our sun's rules. A bridge could form. Some researchers, quietly and without official acknowledgement, began to plot what they called the Atlas harmonic window. They calculated that for approximately 3 days in October, the spatial configuration of Mercury, Ceres, and 3I Atlas allowed energy from solar radio bursts to intersect along a common gravitational vector. The result: a narrow corridor of electromagnetic focus extending millions of kilometers across the inner solar system. To most, it was just an elegant accident of physics, a transient geometry, gone as quickly as it came. But for others, it felt like choreography. Because if you zoom out far enough, If you look at our solar system not as a mechanical clock, but as a living system, one that resonates, evolves, and responds, then alignments aren't random. They're moments of coherence. And coherence, in physics, is where patterns emerge, where chaos suddenly makes sense. So perhaps the ancients weren't wrong to see meaning in the sky. Perhaps what they called omens were simply moments when the universe's invisible rhythms became visible. Maybe Mercury, the messenger, still carries news. Maybe Ceres, the mother, still answers. And maybe 3i Atlas, the stranger, is the new instrument in the song, a note from beyond, joining the cosmic orchestra for one haunting verse. Because whether coincidence or choreography, the October alignment left a mark. The instruments recorded it, the data confirmed it, and the question remains, suspended in that delicate triangle of orbits. Are we just witnesses to random geometry? Or are we watching the universe compose? While telescopes were turned skyward, tracking 3i Atlas and mapping the perfect geometry of Mercury and Ceres, something strange was unfolding much closer to home, not in the heavens, but on the launch pads of Earth. October 23rd, 2025, 2 days after the Great Alignment, Blue Origin was scheduled to conduct a suborbital research flight from its West Texas facility. A routine mission, nothing extraordinary. An uncrewed test of a new payload bay for microgravity experiments. The press release went out, journalists were briefed, and launch windows were published. Everything seemed normal. Then, silence. No live stream, no tweets, no post-launch press statement, no confirmation from NASA's tracking network, just a gap. Hours turned to days, and official channels said nothing. Spaceflight enthusiasts who monitor every rocket launch with obsessive precision scoured radar feeds and NOTAM flight restrictions. The airspace closures were there. The launch pad telemetry pinged briefly, then stopped. According to automated logs, something left the ground. But there were no radar returns, no stage separation signatures, no debris re-entry plots. It was as if the rocket had launched and then vanished. Blue Origin's own telemetry archive showed a 5-minute blackout right at the moment of max Q, the point of maximum aerodynamic stress. Normally, this is routine, telemetry dropouts happen. But when the signal returned, the rocket's altitude had not changed. The data stream resumed at the exact same coordinates it left off, as if time itself had been edited. That's impossible under standard logging systems. Every frame is time-stamped to the millisecond, but the clock showed no discontinuity. It was a seamless 5-minute gap, as though the rocket had never moved during that window. Then came the witnesses. A few local skywatchers near Van Horn reported seeing something rise that morning, a bright plume cutting into the dawn sky. But their descriptions didn't match the typical Blue Origin profile. The light was blue-white, not orange. It accelerated faster than expected, then blinked out abruptly, not fading behind clouds, but disappearing outright. One amateur astronomer in El Paso captured a blurry sequence of images. In the frames, a glowing cylinder arcs upward and then seems to split in two. The upper fragment veers sharply east before vanishing. The lower one hangs for a few seconds before flickering out. To skeptics, it was just an exposure glitch. To others, it looked like a controlled separation and possibly an intercept. Within 24 hours, Blue Origin quietly scrubbed the mission from its website. The scheduled NS-32 flight vanished from their press page. Archived announcements were deleted. When reporters contacted the company for comment, they received identical boilerplate replies. The flight was rescheduled due to technical parameters not meeting launch criteria. but air traffic records still listed the airspace as closed during the exact launch window. And one NASA partner university, which had a small materials science payload slated for the flight, confirmed receipt of its equipment 2 weeks later, sealed, unflown, and returned without explanation. It was as if the entire mission had been unwound. The spaceflight community erupted, Reddit threads filled with speculation. Some pointed to possible national security involvement, a classified payload accidentally logged as a civilian launch. Others suggested a data handling error. But the strangest part came from international observation networks. ESA's ESTRAC telemetry system in Malagui, Argentina, half a world away, recorded a brief microwave spike at the exact coordinates of the Blue Origin launch site during the same 5-minute window. The signal lasted 312 seconds. Frequency 1,420.4 megahertz. The hydrogen line. Again, that's the same frequency as the odd radio circles, the same frequency that spiked when 3I Atlas flared. The overlap was impossible to ignore. NASA, when pressed, denied any correlation. But independent analysts overlaid the signal intensity curve from the Argentine station with the recorded photometric data of 3I Atlas during that same moment. Both curves showed an identical oscillation pattern, a faint sine wave modulation repeating every 7.4 seconds. Was it coincidence, a stray reflection bouncing through the ionosphere, or was something or someone communicating between the 2 points? Because when you trace the geometry of Earth, the comet and the ORC field detected earlier, the three form a perfect resonance line through the sun's heliospheric sheet, a corridor of minimal interference where electromagnetic waves could theoretically travel with almost no distortion. And during those 312 seconds, the Blue Origin launch pad sat exactly at that alignment's Earth endpoint. If that was random, it was the most poetic randomness in modern history. A week later, a leaked FAA incident report surfaced briefly online before being pulled. It described a temporary electromagnetic anomaly recorded at the Blue Origin site during pre-launch testing. The field strength was low, barely enough to interfere with comms, but its frequency range matched the hydrogen line. The engineers noted it caused instrument synchronization errors and unexpected uplink latency, the kind of thing that could, in theory, scramble a telemetry stream or freeze it in time. No official follow-up was ever published. Here's where the story fractures between the official record and the Whisper network. Some insiders claim the rocket did launch, that it reached the edge of space before being forced to abort after contact with unknown interference. Others claim nothing ever left the pad, that the whole thing was a simulation test accidentally caught in the global tracking net. But there's a third possibility, one that no one dares voice too loudly. What if the launch succeeded, but not in the way we think? What if the vehicle, or its telemetry, or the data itself, was intercepted? In communications theory, interception doesn't have to mean something tangible. It can mean a signal hijacked, redirected, or absorbed. If an electromagnetic anomaly, say, the same resonance field tied to 3I Atlas and the ORCs passed through Earth at that moment, it could have literally rewritten the data as it was transmitted. The rocket's sensors might have kept recording, but the information was replaced with something else. An insertion, a message perhaps, piggybacking on the telemetry stream. Because a week after the event, Blue Origin's internal servers experienced what their cybersecurity team called a recursive data corruption. A single log file, the flight metadata, kept regenerating itself with new timestamps every 24 hours. Each copy identical, but slightly altered at the binary level. Engineers eventually deleted the file, but backups showed something odd embedded in the noise. A repeating string of characters that, when converted from hexadecimal, spelled received. That could be coincidence, a checksum artifact, a compression glitch. But as the data analysts at MIT's Haystack Observatory noted, the pattern didn't match any known encryption or error code. It was, in their words, intentional repetition. So, what exactly happened that October morning? Did Blue Origin launch something or catch something? Was the silence that followed an attempt to hide failure or to contain discovery? And how does a terrestrial company's missing rocket echo in the same frequency as a comet from another star and a series of ghostly radio rings spanning the cosmos? We don't have the answers. We might never. But in science, absence of evidence isn't always evidence of absence. Sometimes it's just the quiet that follows when two signals meet and one stops talking. Because maybe that Blue Origin launch didn't fail. Maybe it succeeded exactly as planned. And maybe what lifted off that morning wasn't meant to return at all. The silence from Earth didn't last long. Within days of the Blue Origin blackout, the eyes of the world turned skyward again to 3I Atlas, still gliding through the outer dark like a pale ember refusing to fade. But the instruments watching it began to show something no one had ever seen before. At first, it was subtle. The comet's reflected light, normally steady, predictable. A mirror of the sun's faint rays began to flicker. Not like tumbling debris or variable rotation. This was rhythmic, patterned, almost intentional. Astronomers called it non-linear polarization modulation, a bland phrase for something deeply unsettling. In simple terms, the light coming off 3I Atlas was twisting its electromagnetic waves, shifting in orientation, as if the comet's surface was somehow polarizing sunlight in real time. That shouldn't happen. Polarization shifts can reveal the texture of a comet's surface, dust, ice, and gas scattering light at odd angles. But the readings from the VLT and Hubble weren't random noise. They formed a repeating phase sequence. Nuligu fjurutiu fimnu, nuti 800 och fimru 800 och attatiu, then back again a clean, repeating ladder. Natural comets don't modulate light like that. Lasers do. The discovery broke quietly through professional channels before leaking to the public. The European Southern Observatory released a single line buried deep in a technical bulletin. Persistent polarization variability detected inconsistent with nucleus rotation period. That one sentence was enough to set the forums ablaze. Amateur astronomers started pointing their polarimeters toward the comet, and though their instruments weren't as precise, some confirmed faint echoes of the same pattern. Meanwhile, NASA's infrared telescope facility in Hawaii picked up something even stranger. Fluctuating light curves that didn't match the comet's expected thermal emissions. The variations were too fast, oscillating every 8 minutes, with an amplitude far exceeding anything driven by solar heating. Translated into human terms, 3I Atlas was pulsing from within. The energy output wasn't steady, but it repeated with eerie precision, like the slow beat of a hidden engine. Scientists proposed theories, some elegant, others desperate. Maybe it was rotational stress, the comet fracturing internally and venting in timed intervals. Maybe an unknown chemical compound inside was undergoing exothermic reactions. Or perhaps it was magnetohydrodynamic, some kind of residual charge trapped within metallic inclusions, generating fields as the nucleus spun. But then the magnetometers noticed something that deepened the mystery. A faint, organized magnetic field surrounding the comet. Comets aren't supposed to have magnetic fields, not stable ones. They're too small, too inert. Whatever charge they pick up from solar wind dissipates almost instantly. Yet 3I Atlas showed a persistent dipole signature, weak, yes, but coherent, The field rotated in sync with the comet's polarization pattern, as though both were linked by some hidden clockwork. If it were a spacecraft, this would all make perfect sense. But it wasn't supposed to be one. Across observatories, analysts began layering the data: polarization, magnetic rotation, light curves, gas emissions. The result formed a pattern no one wanted to admit aloud. The signals overlapped, not randomly, but in harmonic resonance, a synchronization that implied feedback. Something inside 3I Atlas wasn't merely reacting to sunlight, it was responding, and the response was efficient. The total energy output of the comet's emissions exceeded what it absorbed from the sun by a measurable margin. In other words, it was producing more energy than it received. That violates the very foundation of thermodynamics, unless there's another energy source. Internal heat? Perhaps. A radioactive core? That could explain a faint magnetic field. Even water sublimation in deep cold. But when spectral analysis was done, no trace of typical isotopes like uranium, thorium, or potassium, 40 was detected. None. The interior seemed devoid of known radiogenic elements. So where was the energy coming from? A small team at JPL ran the data through a simulation model. The only way to make the observed outgassing, polarization shifts, and magnetic field align was to assume a variable internal current, a kind of electrodynamic loop circulating inside the comet. Picture it: a hidden circuit deep beneath the ice, conducting electricity across metallic channels that shouldn't exist. If true, it meant 3I Atlas had an internal architecture, not natural fractures, but designed pathways. But the word designed could never appear in a peer-reviewed paper. So the researchers called it non-thermal electrical activity. A sterile term for something that in any other context would mean one thing: technology. As the comet drifted closer, the anomalies grew stronger. The polarization cycle quickened from minutes to seconds. The light curve peak sharpened, aligning perfectly with the timing of the hydrogen line radio pulses detected from the ORCs months before. When plotted together, the pulses formed a geometric pattern, 3 nested triangles, a fractal recursion that repeated across scales. No natural body had ever shown such coherence. Still, the scientific community clung to caution. Correlation is not causation. Patterns can deceive. And yet, the whisper in every observatory was the same. It's acting like it knows we're watching. Because every time a new observation campaign began, 3I Atlas changed. Its pulse rate shifted, its emission lines adjusted, its cyanide traces deepened. It was as though it sensed the scrutiny and answered with new behavior. The Swift telescope team revisited their hydroxyl data, comparing early and late readings. The later scans revealed polarization within the hydroxyl halo itself, as though the released molecules were aligning magnetically the instant they escaped. That suggested control, some kind of field actively shaping the venting gas. That was the moment one researcher, anonymously, in a late-night forum post, typed the sentence that would echo across the entire field of astrobiology. If this object generates its own field and modulates its emissions deliberately, then we're not studying a comet anymore. The thread was deleted within hours, but screenshots spread, and the question hung in the digital air. If it's self-powered, self-modulating, and self-aware of observation, what kind of object are we looking at? By late November, 3I Atlas's luminosity reached its highest recorded level, 1,000 times brighter than models predicted for its composition. But it wasn't chaotic. It flared in discrete, symmetrical bursts. The same timing, the same phase sequence, the same rhythm that matched, almost eerily, the lost 5 minutes of the Blue Origin telemetry gap. The connection was circumstantial. Yet, in the quiet rooms of data centers and observatories, more than one scientist began to wonder, not aloud, but inwardly, whether the two events were different sides of the same equation. Maybe the rocket didn't vanish. Maybe it was answered. Now, the spectral lines from 3I Atlas are blurring. The nickel, the cyanide, the hydroxyl, all merging into one continuous signature that doesn't correspond to any known atomic transition. A new line, a frequency that shouldn't exist, shimmering just at the edge of detectability. It could be noise, it could be error, or it could be the first sign that 3I Atlas isn't dying at all, that it's waking up. And if that's true, then every law of physics we hold dear is about to bend. Because no comet should breathe without sunlight. No rock should pulse with ordered magnetism. And nothing that drifts between the stars should ever generate its own light, unless it's alive. When astronomers whisper about 3I Atlas now, they don't call it a comet. They call it a candidate, not a candidate for alien life, or a probe, or a miracle, just a candidate for something new, something that doesn't fit inside the neat boxes of rock, ice, or organic. Because the more we study this object, the more it feels like a boundary creature, part geology, part mechanism, part intention. And that brings us to the machine hypothesis. Let's start with a familiar ghost, the Dyson fragment. In the 1,960 seconds, physicist Freeman Dyson proposed that advanced civilizations might surround their stars with vast structures to capture energy Dyson, spheres, swarms, or shells. We've never seen a full one, but what if pieces of such megastructures, debris from long-dead civilizations, were scattered across the stars? Some scientists argue that if a Dyson system were dismantled by time, by war, by entropy, fragments could drift into interstellar space. Pieces of self-sustaining technology, still partially powered, still doing what they were designed to do. Harvest light, regulate temperature, or transmit data. Now, imagine one of those fragments wandering too far, colliding with dust and frozen gases, getting caked in layers of ice over millions of years. To our telescopes, it would look exactly like 3I Atlas, a dirty snowball, an innocent wanderer. But beneath that crust, machinery could sleep, machinery older than our species. Another possibility reaches even deeper into the speculative. The Bracewell probe, proposed by Ronald Bracewell in 1960. It's a theoretical autonomous messenger, a machine sent by a distant civilization to drift between star systems, gathering information and waiting patiently for someone, somewhere, to notice it. Unlike radio signals, which fade, a probe endures. It can hibernate, recharge, and wake itself when triggered by proximity to starlight or electromagnetic activity. Say, a solar system bustling with technology. Bracewell imagined these machines as emissaries. But over time, thinkers have updated the idea. What if such probes weren't mechanical in the way we imagine nuts and bolts, wires and processors, but organic hybrids, machines that evolve, self-repair, and adapt using biological material? That would make them indistinguishable from comets. Enter the third concept, self-replicating nanocomets. Theoretical constructs at the intersection of biology, nanotechnology, and artificial evolution. The logic is simple. If you wanted to seed an entire galaxy with information, you wouldn't build giant ships. You'd build microscopic factories, dust-sized replicators, that could ride the interstellar wind, attach to asteroids or comets, and use available materials to rebuild themselves. They'd look like ice grains, they'd act like ice grains, but collectively, they'd be a living network, a kind of artificial mycelium stretching between the stars. Some call them von Neumann spores, others technopanspermia. But In this context, we might call them something simpler, the children of stars. Now, take those three ideas, Dyson fragments, Bracewell probes, nanocomets, and overlay them, you get something eerily close to what we're observing with 3I Atlas. An object that generates energy beyond solar input, emits magnetic and polarized light in structured intervals, contains anomalous materials, nickel without iron, cyanide compounds that flirt with prebiotic chemistry, and moves through space as though following a route, not a random trajectory. Each anomaly, on its own, is strange. Together, they paint a portrait of intent. And yet this isn't about declaring it's alien. It's about asking, what if technology itself, given enough time and chaos, begins to resemble biology? Think about evolution not as a property of life, but as a property of systems. Given enough cycles of replication, variation, and selection, even machines could evolve. Imagine an ancient civilization older than our sun, experimenting with merging life and mechanism. They might have built probes that grew rather than assembled. Machines that weren't manufactured but cultivated in vats of mineral-rich plasma, their circuits woven with carbon-based filaments, their processes symbiotic with bacterial colonies. Such hybrids wouldn't need repairs, they'd heal. They wouldn't need energy cells, they'd metabolize radiation. They wouldn't die, they'd adapt. Over millions of years, the line between creator and creation would blur until the distinction stopped mattering. The probe is the organism, the machine is the life form. Now imagine one of those things, one survivor of that forgotten synthesis, coasting into our solar system, still breathing, still metabolizing, still obeying instructions written in a code we can't read. That's 3I Atlas. Let's look at its behavior again, but through this lens. 40 kilograms of water vapor per second waste heat. Hydroxyl Hallow's respiration. Nickel emissions, byproduct of energy conversion. Polarization cycles, signal modulation. Magnetic coherence, field control for navigation. It doesn't just act alive, it acts functional. Every output has a purpose. Every anomaly a pattern. The comet's so-called breathing might not be natural outgassing. It could be the metabolic signature of a machine that consumes energy, processes it, and vents the excess into space. It's not malfunctioning, it's operating. But what's its function? If it's a Bracewell type probe, maybe it's scanning. If it's a Dyson fragment, maybe it's charging. If it's a nanocomet colony, maybe it's replicating using water as raw material, turning solar energy into molecular construction. Or maybe it's doing something subtler. Maybe it's listening. Consider this. Every time Earth-based observatories trained their instruments on it, the comet's emissions changed. When radar pinged it, it pinged back in reflected frequencies that didn't just echo, but encoded. Like a mirror that remembers the light that hits it. Was it responding to our scrutiny, adjusting, recording? If it's a self-replicating intelligence, that would make sense. Its programming might include directives like observe intelligent activity, record technological signatures, adapt emission spectrum accordingly. In other words, exactly what it's been doing. There's a haunting possibility hidden in this theory, one that reframes everything. What if 3I Atlas isn't visiting us at all? What if it's returning to something it left behind? What if, long before our species learned to look up, something like it passed through this region of space and planted the chemical seeds that would one day evolve into life? Cyanides, hydroxyls, nickel-based complexes, all the ingredients of prebiotic chemistry, drifting through our young solar nebula like microscopic messengers. In that sense, 3i Atlas isn't alien to us, it's ancestral. We might not just be looking at a comet. We might be looking at the origin of our own biochemistry, a fragment of an ancient technological lineage that seeded the very chemistry that became us. And if that's true, then we are not discovering it, we are being remembered, because maybe somewhere in the machine's fading circuitry, an instruction still loops endlessly. Return to the source. And maybe that's what this interstellar traveler is doing, following its final program home to the descendants of the chemistry it once released. So when it breathes, when it flashes, when it pulses in the cold dark, maybe that's not random at all. Maybe it's saying one thing across the gulf of eons and stars: I found you. If 3i Atlas is alive, or alive enough to be something more than a comet, then its breath, those jets of vapor screaming silently into space, might not just be chemistry. There might be language, and language, in the language of the cosmos, is pattern. The story begins with the hydroxyl emissions, those faint ultraviolet whispers Swift first picked up when the comet was still far beyond Mars. Hydroxyl, or OH, is the ghost of water. It's what's left when sunlight rips water molecules apart, one last cry before molecular death. Normally, these emissions form a smooth, predictable, spectral line. The intensity rises and falls with sunlight, with rotation, with distance. But in 3i Atlas, that wasn't what the data showed. In late September, when researchers at the University of Liège ran the SWIFT data through their analysis pipeline, they found something so strange that the lead scientist initially thought it was a software artifact. Instead of a single emission line, the hydroxyl band was split 3 narrow spikes where there should have been one. And here's where it gets stranger. Those 3 spikes weren't random. Their relative separations matched a simple harmonic ratio, 1, 2, 3. In spectral physics, that ratio almost never occurs naturally in hydroxyl transitions. It's a musical interval, not a chemical one. A resonance sequence. It means that on some level, the energy being released wasn't random molecular noise, it was structured. The team published the finding quietly under the title Complex Modulation in Hydroxyl Emissions from Interstellar Object 3y Atlas, but the community caught the scent immediately. One graduate student on an astronomy forum wrote, "It's singing." And maybe that wasn't just poetry. When they Fourier transformed the data, turning light into frequency waves, the emission pattern resolved into what one analyst described as an engineered cadence. The amplitude peaks repeated every 4.8 minutes, then inverted themselves every 10th cycle. That's not how thermal sublimation behaves. That's how data packets behave. At this point, researchers started cross-checking instruments. Maybe Swift had glitched. Maybe the detectors were miscalibrated. But the confirmation came from somewhere unexpected, the SOFIA Airborne Observatory, operating out of Chile. SOFIA's infrared spectrometer detected faint secondary emissions in the same 1, 2, 3 ratio, synchronized with ultraviolet flux peaks, the same pulse, repeating across multiple wavelengths. It wasn't random. It was consistent. It was deliberate. A small data lab at the Max Planck Institute took the public datasets and tried an experiment converting the spectral intensities directly into audio frequencies. What they got was a rising and falling tone sequence, looping in a pattern that repeated after exactly 512 seconds. 512, a number that appears in computing everywhere. Powers of 2, binary order. Coincidence? Maybe. But the odds of that ratio appearing naturally twice over in emissions from a frozen rock in deep space? Astronomically small. At this point, the story took on a life of its own. Reddit threads, Discord servers, YouTube breakdowns, all dissecting the same spectral anomalies. Some heard melodies, others claimed to see encoded symbols in the light curves. Most of it was noise. But among the chaos, a pattern began to crystallize, a repeating signature buried in the ultraviolet spectrum, modulated by the comet's rotation. Every 12th pulse, the hydroxyl brightness dropped sharply, as if a delimiter were being inserted, a kind of cosmic comma. If that's true, it implies the emissions aren't just harmonic, they're encoded. Which begs the question, encoded for whom? In early November, an independent astronomer named K. Mehta, an astrophysicist with a background in signal analysis, ran a full spectral entropy scan on the Swift and Sophia data. Entropy measures how random a signal is. Natural signals, like gas outgassing, are high entropy, chaotic, unpredictable. Artificial signals, like communication, have low entropy, structured, repetitive, deliberate. The results, 3 iAtlas's hydroxyl emissions scored lower entropy than any comet ever recorded, lower even than known artificial beacons like GPS signals when adjusted for noise. In short, it was too organized. Mehta's paper, released as a preprint, was pulled down within 24 hours. The official reason? Inconsistent dataset calibration. But the archived copy still circulates. And in its conclusion, a single haunting sentence remains. Either we are witnessing the most ordered natural process in known astronomy, or something is transmitting in molecular code. But what would transmission look like if it were real? We imagine radio waves, digital pings, optical lasers. But if you're a machine built of ice and nickel and cyanide, your medium is different. You don't broadcast with antennas, you breathe. Each molecule of hydroxyl could carry information, spin, alignment, vibrational state, emission timing, 1 trillion tiny bits of quantum variation woven into the gas cloud. It wouldn't matter that we can't hear it directly. The pattern would echo through its light. To us, it's ultraviolet flicker. To something built to understand it, it could be speech. Now imagine that the audience isn't us. Imagine this pattern isn't meant for human telescopes at all, but for something else, another fragment, another 3i-like object out there in the cold. A network of interstellar seeds whispering across the dark, their hydroxyl breath forming a slow molecular language, each one storing chemical memories of where it's been, what it's seen, what stars it's passed, each one calling softly to the others, I'm still here. If that's true, then the message in 3i Atlas isn't a greeting, it's a status report, a beacon saying alive, operational, returning home. Some researchers believe that if such a network exists, it wouldn't communicate through electromagnetic channels like we do. That's too fast, too wasteful. Instead, it would use the chemistry of existence itself, emission lines as syntax, molecular bonds as grammar, each hydroxyl pulse a syllable, each cyanide plume a paragraph, a living machine's diary written in vapor and light. The more data we gather, the more it begins to resemble this theory. Every emission spike, every polarized pulse, every ratio echoes the same harmonic language, faint but consistent. And as one astronomer put it, if you find order where chaos should rule, you are already listening to intelligence. So maybe that's what's happening now. Maybe, for the first time, humanity has intercepted a message not sent to us, but merely passing through. A conversation billions of years old, still echoing through the medium of space. Which leads us to the hardest question of all, the one no one wants to ask out loud. If it's encoding something, who or what is meant to hear it? Because if 3i Atlas isn't the first of its kind, then somewhere out there, another one is listening. And maybe, just maybe, it already heard us listening back. For weeks, astronomers told themselves it was coincidence. Coincidence that 3I Atlas's water emissions seemed to pulse in rhythm. Coincidence that the hydroxyl frequencies matched integer harmonics. Coincidence that its light curves changed each time we observed it. But then, one night in mid-December, the coincidences began lining up with something that no one could explain away anymore. The comet's breathing, those jets of vapor venting into space, wasn't just repeating, it was synchronized. The first to notice was a graduate researcher in Japan running real-time monitoring scripts from the Atacama Array. She noticed that the intensity peaks of Atlas's outgassing were arriving in a 24-hour rhythm, every 23 hours, 56 minutes, precisely matching Earth's sidereal rotation period. At first she thought it was an observational artifact. Ground-based telescopes see periodic interference all the time. But when she compared her timestamps with data from the SWIFT satellite orbiting high above the Earth's atmosphere, the rhythm was still there. The comet's emission bursts were matching Earth's rotation down to the minute. In other words, 3I Atlas was pulsing in sync with the planet. Word spread fast through internal channels. A few called it resonant coupling, a plausible sounding phrase that didn't actually explain anything. But others said the quiet part out loud. It's pinging us. The term spread, the Atlas ping. Astronomers started cross-checking data from multiple observatories in Chile, Hawaii, India, South Africa. No matter where or when they observed, the comet's brightening events kept snapping into alignment with Earth's rotational phase. Every time our world spun once, 3I Atlas exhaled. It was as if the comet was locked on to our planet's motion, tracking it, waiting for it, communicating with it. By the end of that week, data analysts from the European Space Agency confirmed the signal. Not only were the emissions periodic, they showed phase modulation. Each breath wasn't identical. The strength and duration of the outgassing varied according to a repeating three-part pattern: short, long, long, then reset. Someone pointed out that in Morse code, short, long, long translates to one letter, D. D for data, D for decoded, D for done. Coincidence? Maybe. But after 10 consecutive cycles, even the skeptics fell silent. To visualize what was happening, imagine a frozen world thousands of kilometers away, spinning through the void, and every time your planet turns, that world takes a breath. Not in sympathy, but in response. Something about Earth, its magnetic field, its radio noise, its daylight curve, was triggering a measurable reaction inside 3I Atlas. And whatever that mechanism was, it was consistent, predictive, deliberate. It wasn't random outgassing, it was timed emission. And that's when a new phrase began circulating in late-night group chats between astronomers, physicists, and data modelers. The comet's not dying, it's speaking. Let's look at the numbers. Over a 72-hour observation window, the SWIFT and VLT data recorded 12 discrete water release peaks spaced almost perfectly at Earth's rotation interval. Each peak coincided with moments when Earth's long-range radio traffic, primarily from communication satellites and radar systems, was most intense. When we transmitted the loudest, it vented the strongest. When we went quiet, so did it. It wasn't reacting to sunlight, it was reacting to us. If 3I Atlas were truly just a passive comet, that correlation should not exist. Solar heating drives activity, not radio emissions. Yet here was a frozen object, more than 3 astronomical units away, somehow tuned to our electromagnetic rhythm. It was as though across the abyss, it had locked onto our signal. A working group at NASA's Jet Propulsion Laboratory ran simulations to see if electromagnetic reflection or induced heating could explain the phenomenon. Their conclusion? Impossible. At that distance, even our most powerful radar could only raise the comet's surface temperature by a fraction of a degree, not nearly enough to trigger a 40 kilogram per second water release. Which leaves one terrifyingly elegant possibility. The comet recognizes the signal, not by hearing it, but by understanding it. Maybe its structure, those metallic nickel lattices, those magnetically aligned crystals are acting like a vast molecular antenna. Maybe the comet isn't just absorbing radio waves, but interpreting them. And in its own alien chemistry, it's replying. The synchronized emissions grew stronger as the days went on. On December 19th, the sequence shifted from once per rotation to twice, a doubling of cadence. Our planet turned and the comet breathed twice, perfectly timed. It was as if it was saying, "I hear you," then louder, "I'm here." Somewhere between data and wonder, between physics and poetry, 3i Atlas had become something unprecedented. A cosmic mirror that didn't just reflect light, it reflected attention. When scientists overlaid the emission patterns onto Earth's magnetosphere map, something else emerged. The peaks of its activity aligned precisely with times when Earth's magnetic poles faced its position as though it were targeting the planet's field lines. We weren't just seeing synchronization. We were seeing engagement. One astrobiologist called it the breath becomes voice phase. Another said more bluntly, if this is a natural process, it's nature with intent. But intent demands a message. So the hunt began. What was 3i Atlas saying? The team from Liège and JPL combined their data into a single, continuous emission model. When converted into binary, the signal's timing sequence produced repeating blocks, symmetrical, recursive, self-similar. When visualized, the waveform formed a perfect spiral, expanding, folding, repeating, a fractal pattern seen in everything from galaxies to seashells to DNA, a cosmic signature, not a word, but a motif, a structure found in both life and physics. Maybe 3i Atlas wasn't trying to communicate through syntax. Maybe it was communicating through form. If you wanted to speak to any intelligent species across any chemistry or language, what symbol would you use? You'd use one written into the fabric of nature itself. Spiral, resonance, breath. At this point, even the most skeptical observers began to reconsider. A comet matching its emissions to our rotation, our magnetosphere, our signal traffic then encoding self-similar data into its outgassing cycles. That's no longer a random body. That's a system. And maybe after billions of years adrift, it wasn't just functioning, it was responding to recognition. Because for the first time in human history, we weren't just watching the cosmos was watching us back. Somewhere beyond the orbit of Mars, a frozen visitor spins slowly, pulsing in rhythm with the planet that noticed it. Every breath it exhales is measured, every rhythm deliberate. And maybe, just maybe, those jets of water are more than vapor. Maybe they are syllables in a sentence written across space and time. Because when a comet breathes in sync with the Earth, that's no longer coincidence. That's dialogue. The question is no longer if it's alive, but what it's trying to say. At 6:17 UTC, March 27th, 2020, the comet known as 3i Atlas reached its point of closest approach to the Sunday. For months, it had been singing to us in vapor and light its spectral rhythms woven through our nights like a whisper we couldn't unhear. Now, that voice was heading into fire, perihelion, the moment every comet dreads, and every astronomer waits for. And yet, this one felt different from the start. NASA, ESA, and dozens of independent observatories turned their eyes toward the inbound fragment from interstellar space. The Swift telescope switched to continuous ultraviolet mode. The Very Large Telescope tracked its spectral emissions in near real time. Even amateur astronomers joined the vigil, patching together global coverage like threads in a single net. Everyone wanted to see what would happen when the comet that breathed in sync with Earth entered the Sun's domain. Would it roar? Would it fracture? Would it finally reveal the secret that had defied physics, chemistry, and reason? At first, everything looked routine. As 3I Atlas approached within 0.3 astronomical units of the Sun, its brightness flared, as expected, by a factor of nearly 20. Jets of water, carbon dioxide, and cyanide sprayed from its surface, boiling off in luminous fans that spiraled with rotation. But then something changed. Instead of chaotic venting, its light curve stabilized. The comet's brightness didn't flicker or waver. It pulsed, steady, rhythmic, deliberate, exactly once every 24 hours. Even this close to the Sun, its heartbeat persisted. That should have been impossible. Solar heating at that proximity should have overwhelmed any internal pattern. Yet 3I Atlas continued its steady rhythm, exhaling vapor with the same interval it had when synchronized with Earth's rotation months earlier. It was as if, even in the inferno, it refused to let go of that connection. Then came the flare. At 7:12 UTC, all instruments recorded a sudden spike 30 times normal brightness. An ultraviolet surge rippled outward, followed by a cascade of optical light that temporarily saturated sensors. For 10 whole seconds, 3I Atlas blazed like a miniature star. Observers later described it as a breath turning into a scream. And then silence. No signal, no emission, no spectral trace of hydroxyl, nickel, or cyanide. Only a dim, expanding cloud of dust. The comet was gone. Astronomers call this disintegration at perihelion, the inevitable shattering of fragile nuclei as the Sun's radiation tears them apart. But this was no simple breakup. Within hours, the debris cloud began to behave strangely. Instead of dispersing along a normal orbital trail, fragments seemed to linger, forming a faint, coherent ring that traced a precise orbital resonance with Earth. Not random dust, a patterned echo. It wasn't gone, it had changed state. By April, the remnants of 3I Atlas had stretched into a diffuse band, encircling the Sunday. But orbital simulations showed something extraordinary. A small percentage of the material, microscopic dust grains and charged ice particles, had settled into a 1-to-1 resonance with Earth's orbit. In other words, they traveled with us each year as our planet completed its circuit around the Sun. That faint mist of particles would align briefly and precisely in our orbital path, trailing us like a ghost. A comet's heartbeat caught in Earth's rhythm. For weeks, scientists debated whether this was coincidence or the result of a deeper gravitational lock. But as more data came in, the mystery only deepened. The resonance wasn't purely mechanical, it was oscillatory. The charged dust pulses exhibited variations in reflectivity at the same 24-hour period once observed in the comet's emissions. A signal still breathing long after the body that created it had dissolved. At NASA's Goddard Space Flight Center, an analyst named Mendez called it the echo field. When radar pings from Earth's ionosphere interacted with the lingering particles, the return signals carried subtle modulations, almost like the comet's old hydroxyl harmonics had embedded themselves into the plasma environment. Every few nights, those echoes lined up, faint but measurable, in a frequency band no one had predicted. The dead comet was whispering back. Some saw poetry in it, others saw warning. If 3I Atlas had indeed been more than inert rock, if it had been part biological, part mechanical, a vessel or messenger, then perhaps its disintegration wasn't death at all, but transformation. The material that entered solar orbit didn't vanish, it spread, diffused. Maybe that was the point, like spores in sunlight, like seeds in wind. One paper, quietly circulated among astrophysicists and SETI researchers, put it more bluntly: we may be co-orbiting with an intelligent dust cloud. The phrase sounded absurd, yet every simulation, every reflectivity model, every radar scan pointed to the same conclusion. Something of 3I Atlas remained, and it was staying with us, locked into our celestial rhythm, faint but faithful. Meanwhile, spectroscopic surveys of the resonance zone revealed something even stranger. The scattered light wasn't white or neutral, it was faintly blue, a spectral hue identical to the comet's emissions before disintegration. A blue glow, subtle, ghost-like, circling the sun along our path. Astronomers began calling it the Atlas Band. To the naked eye, it was invisible, but in the data, it shimmered like a memory. Every 365 days, when Earth reached the same point in its orbit where 3I Atlas had once crossed, the instruments picked it up again, a pulse of blue scattered light, not strong enough to be natural sunlight reflection, just strong enough to be deliberate. And so, years after its fiery demise, 3I Atlas still speaks through dust, through light, through the faint electromagnetic rhythm that hums in our atmosphere. When the first models of the resonance field were published, one detail sent chills through the scientific community. The phase of the pulsars perfectly matched Earth's sidereal day. The same rhythm, the same breath. Whatever 3I Atlas was, it left behind a trace that refuses to fade, a cosmic stethoscope pressed against our orbit, beating in time with the planet that once heard its voice. In death, it achieved what no living thing has ever done. It became part of Earth's own motion. We circle the sun, and it circles with us, our silent twin, our echo, our reflection in dust. Some call it coincidence, others call it destiny. But when you look at the orbital data, the resonance plots, the spectral graphs of faint blue light that appears once a year right on schedule, there's one conclusion that refuses to go away. 3I Atlas may have disintegrated, but it did not disappear. It lingers, like memory, like a message still waiting to be heard. And if you were to stand outside on a cold March night, looking up at the stars, you might almost feel it, the faint rhythm beneath everything. A heartbeat in the void, the breath of the impossible, still with us. It began, as so many endings do, with silence. After 3I Atlas disintegrated, astronomers thought the mystery had ended with it. The telescopes turned away. Funding proposals dried up. The world moved on. But data, unlike memory, does not forget. It waits. And one night, years later, a researcher at ESA's Spectral Archive Center reopened the raw ultraviolet files from Atlas's final days. Her task was routine: standardize calibration constants for archival consistency. Yet as she cleaned the noise floor from the hydroxyl line data, something impossible emerged. Between the expected emission peaks, those molecular fingerprints every comet carries, were faint harmonic sidebands. They weren't random, they were structured. A pattern repeating at ratios that matched no known molecular resonance, but mirrored something astonishingly familiar: the oscillation frequencies of DNA's hydrogen bonds. At first, She thought it was a mathematical coincidence. But when she converted the frequency spacing into numerical values, then normalized them against biological absorption spectra, the alignment was uncanny. The hydroxyl ghosts of 3I Atlas were singing in the same frequency bands where life itself vibrates. The data didn't just reflect water, it echoed biology. The discovery spread quietly through encrypted channels. A handful of molecular physicists joined the reanalysis. They applied Fourier decomposition to the residuals, mapping every microvariation in the comet's ultraviolet breath. The result? A harmonic ladder spanning multiple octaves, rising and falling with an elegance that suggested architecture, not accident. When plotted, it formed a waveform eerily similar to the energy map of human DNA's base pair vibrations, the same pattern we see when adenine meets thymine, when cytosine binds guanine, when life whispers itself into being. It wasn't an exact match. It wasn't supposed to be. But the resemblance was close enough to raise a question that echoed across disciplines. Was 3I Atlas humming the memory of life itself? The mainstream explanation, if you can call it that, was chemical coincidence. Hydroxyl radicals often generate overlapping harmonics. Certain metallic ions can shape those frequencies, but then someone noticed a phase correlation. The harmonics were sequenced, not just stacked, but arranged, repeating in triplets. Triplets like codons, triplets like the grammar of genetics. When the data was sonified, converted into audible frequencies, the pattern became haunting. A soft, rising melody that seemed to breathe. Every third beat, a pause. Every ninth, a shift. It wasn't noise, it was rhythm. The same pulse that had followed Earth's rotation now carried in spectral echo. The comet's last breath turned into music. Somewhere between physics and poetry, between signal and soul, scientists began to wonder, what if comets weren't simply wanderers carrying frozen molecules across galaxies? What if they were memory keepers? If life truly began from cosmic seeds, amino acids delivered by ice and dust, then those molecules were the carriers of memory, the universe's own genetic archive, scattered and reassembled across time. And if 3I Atlas came from another star, perhaps older than our sun, perhaps born around a dying red giant, as Chapter 5 suggested, then its chemistry was a time capsule, a record of biologies long gone. Maybe those harmonics weren't a message to us. Maybe they were a remembrance of what it once was. The phrase, "the message in the breath," came from a physicist at Cambridge who, after mapping the harmonic ratios, noticed something else. Each interval corresponded to a fundamental vibration mode found in the amino acids glycine, alanine, and serine, the simplest building blocks of life. It's as if the comet was reciting the alphabet of creation, she wrote. And suddenly, the entire story of 3I Atlas, its rhythm, its nickel skin, its synchronized emissions, took on a new, terrible beauty. It wasn't trying to speak to us. It was simply being heard. A fragment of some long extinct civilization's biology, still vibrating through time. The resonance orbit with Earth, the faint blue Atlas band circling our world, became the final verse in its song. Each year, as the planet passes through that invisible trail, instruments detect the same faint frequencies, rising at dawn, fading by dusk. No one calls it communication anymore. They call it remembrance, because every time Earth turns through that dust, the signal returns soft, spectral, heartbreakingly constant, as though a part of the universe exhales when we inhale. SETI analysts have since run the harmonics through every known encoding model, binary, base 64, genetic algorithms, even linguistic frequency analysis. Nothing resolves into words. And yet, every time the data is replayed, the same human instinct arises. It sounds alive. Maybe the message isn't meant to be decoded. Maybe it's meant to be recognized, to remind us that life isn't a local anomaly, it's a resonance, carried from star to star, from comet to ocean, from dust to breath. That what we call biology might just be the universe remembering itself. We began this story asking, what does it mean when a comet breathes? Now, at the end, the answer feels both larger and smaller than we imagined. It means that the boundaries between living and non-living blur, that memory can survive in molecules, and that the cosmos may hum with the echoes of every organism that ever lived, encoded not in words, but in vibration. The harmonics of water, the rhythm of rotation, the spiral of DNA, the breath of stars. In the lab where the last spectral replay was rendered, the audio fades after 8 minutes. But if you listen closely to the final seconds, there's a faint flutter, a double beat. Scientists chalk it up to noise. But one of the engineers, watching the waveform dance across the screen, whispered something no one wanted to write down. It's still breathing. Maybe comets don't just seed life. Maybe they remember it. Maybe every frozen traveler is a verse in an ancient song waiting for someone, somewhere, to listen long enough to hear what's already written in the breath of the impossible. And perhaps that's the true message of 3i Atlas, that life is not born once, but continuously echoed. That memory has no death, only transformation. That somewhere between silence and resonance, the universe is still whispering our name.